So taking a look at B, we're going to do the same thing. Again, as a rule of thumb, easiest way is to shift it last. So I'm going to take a look at my Y transformation, and before I do the flip first and expand second, here it doesn't really matter. We can do those either way, so either order. So I'm going to do my expansion first. So taking a look at the original height of the blue graph, its original height of 5, and the green graph has a height of 10. That's a vertical expansion by 2. Okay, and I can also see that the vertex is down on the blue graph and the vertex is up on the red graph. So I know I have a vertical flip. Okay, so that's the first thing I'm going to do. Okay, I also can see that when I flip and expand it, I'm going to have my vertex at 0. Okay, so I'm going to keep it at 0. I'm going to use this as my reference point here. Okay, and that's going to end up at this reference point here. I know that there's going to be a vertical shift that I'm going to have to do to get it in the right spot. Okay, and I can see actually right now it's going to be +2. But I'm going to show a process here. So I'm going to keep track of my Y coordinate. So I'm going to start with my Y coordinate of 0. So my starting Y, my start Y is 0, so I get Y equals 0. I'm going to do my transformation on it. My first transformation is times by -2. And I'm going to get times by -2 on 0. So that's just going to remain in the same place. Okay, and then I need to do some horizontal vertical shift. My vertical shift is going to be in here. And my end position, so my end, is going to be at Y equals, looks like +2. Y equals 2. So to go from 0 to 2, I need to do +2 as my vertical shift. So my vertical shift is +2. Okay, so again, I do my compression, my expansion, and my flip first, and I shift it last to get into the right spot. So start my function notation out here. It looks like this, f of something, and then on the outside, I'm going to do times by -2 first, and then +2 last. That's my vertical. I now need to work on my horizontal. Looking at the horizontal, it looks like it doesn't look like it's a horizontal expansion or anything. Okay, so nothing happened horizontally. It doesn't look like it flipped horizontally either. So it's the same distance horizontally, and maybe I'll just count it just to make sure. So I'm going to count. This is going to be from here to here across. This is 10 across, and from here to here, this is 10 across as well, right? 3, 4, 5, 6, 7, 8, 9, 10. So that's 10 as well. So there's no horizontal compression or expansion. There's no flip. So it's just a shift. My horizontal shift is going to be +3. So since it's just a shift, I'm just going to write it in the notational form. It's going to be x -3. Okay, so that's what I'm going to put into my notation, x -3. And it's backwards for whatever happened here. It went +3, so my notation should be -3. So there's my function notation with the vertical done separately from my horizontal. And then I did my expansion. I looked at my expansion, compression, and flips first, and then figured out the shift last.